Good morning, students. Today's topic is Introduction to Data Structures. Here, everyone know about this topic. Okay, those who are from computer science background, you know this particular topic. Okay, it's very interesting topic. Nowadays, everywhere anyone is simply speaking about data. Okay, data. It's a big data analytics. Everywhere the data is there. Okay, so here this particular topic is very important. It's very fundamental to all. Okay, those who are in the computer science and engineering computer science field, it's very important topic. Okay, so we see one by one. Okay, we see one by one. Okay, so in this slide simply we see about the definition of data structure. Okay, so here that the first point is data structure is representation of the logical relationship existing between individual elements of data. Okay, so that's a logical relationship between individual elements of data. Okay, that's a representation. Data structure is the representation of the logical relationship existing between individual elements of data. Okay, so but normally we say data structure is a way of organizing all data items. So organizing the data and also store those data in the memory. Okay, so that's important thing, students. Okay, data structure is a way of organizing all data items that considers not only the elements stored but also the relationship to each other. Okay, so here we want to clarify that. Okay, we organizing and also storing the data. So not only to simply store the data. So here we say the relationship to each other. Okay, for example, if you want to store the data for a student information, okay, in that you want to store student roll number, student name, in date of birth, which branch he or she studying. In this way, you want to store these four type of data means here there is a relationship existing between each and every individual element of data. Okay, so the roll number is belongs to a particular student. Okay, so the branch is belongs to that particular student. The date of birth also belongs to that particular student or that particular roll number. Okay, so that's only here explained in this slide. Okay, so simply it's not only way of organizing and also storing the data, and also here we use their relationship to each other. Okay, so in this way here we concentrate each and everything. Okay, each and everything means storing, organizing, and also using the relationship. Okay, so here you concentrate more and more about the structure. Okay, how we store the data. Okay, and also if you want to know more about that relationship means you want to concentrate the subject database management systems. Okay, DBMS. Nowadays it is available in so many titles. Okay, that is RDBMS or RDBMS. Okay, in this way there are so many flowers are there. You can learn any one of them. Okay, if you want to learn DBMS means the best is now ORDBMS, and also you can learn ORDBMS, DBMS. Okay, so that's important thing, guys. Okay, now we move to the next slide. It also another introduction slide. See this, data structure affects the design of both structural and functional aspects of a program. Okay, here we concentrate both structural and also functional aspects of a program. Okay, then if you consider a single program, that program may be combination of both algorithm and data structure. Okay, that's a program is equal to algorithm plus data structure. Okay, then you know that an algorithm is a step-by-step procedure to solve a particular function. Okay, if you want to know about an algorithm, that is nothing but step-by-step procedure to solve a particular function. That is an algorithm. So with that algorithm, we can add data. So we want to give some input, we want to get some output. So therefore, that's a algorithm plus data structure. Okay, so then only we will get it as a program. Okay, so in this slide, if we want to know two things. One is data structures affects the design of both structural and functional aspects of a program. Okay, in a program, data structure play an important role. And another information is, okay, if you want to create a program, within that you want to combine both. One is an algorithm, another one is a data structure. Okay, so that's important thing, guys. Okay, so we move to the next slide. It also the continuation of introduction. That means algorithm is a set of instructions written to carry out certain tasks, and the data structure is the way of organizing the data with the logical relationship retained. Okay, so that we already discussed in the previous slides. Okay, so the next point is to develop a program of an algorithm. We should select an appropriate data structure for that an algorithm. Okay, later we will see what are the data structures are there, how we want to choose a particular data structure for a particular program. Okay, for a particular situation, we want to choose which data structure. Okay, that's the thing we will discuss in the next slides. Okay, so the last point is, therefore, algorithm and its associated data structures from a program. Algorithm and its associated data structures from a program. Okay, so here in every slide they simply concentrate two things. Okay, one is without data structure there is no meaning of an program, and if you have a data structure and also we need additionally algorithm also. Okay, so when you combine both algorithm data structure, then only you will have a meaningful structure. So that is a program. Okay, so here we classify the data structure. Okay, there's a classification of data structure that is divided into two broad categories. One is primitive data structure, another one is non-primitive data structure. Okay, primitive, non-primitive. So see here, what are the primitive, what are the non-primitive? Okay, here we see about only primitive data structures. That is integer, float, character, pointer. These are all primitive data structures. And also we have some non-primitives also. See this non-primitive data structure, that is linear. See here, linear list, non-linear list. Again, that non-primitive DS is divided into two subtypes. So that is linear list, non-linear list. Okay. So under the linear list, array is there, linked list is there, stack and queue. Again, the linear list is divided into four. That is an array, linked list, stack, queue. Then under the non-linear list, two type of data structures are there. One is a graph, another one is a tree. Okay. So totally under the non-primitive data types, around 6 type of data structures are there. Okay. Under non-primitive. In primitive, around 3 to 4 data structures are there. Okay. So here we concentrate stack, queue in our in the next videos. In our next videos, we concentrate only about stack, queue, linked list, okay, graph and the trees. Okay, we'll make a separate video for a stack operations, separate for queue operations, graph and trees. So today we see only up to an array. So in this video, we mainly concentrate only about an array. Okay. So here, primitive data structure. Primitive means that is a basic data structure. We can store only one value, okay, at a time. That like that. Okay, that is a basic. That's a primitive data structure. Okay, there are basic structures and stately operated upon by the machine instructions. In general, there are different representation on different computers. So it may differ. The representation is differ in different computers. Integers, floating point number, character constants, string constants, pointers, etc. fall in this category. Okay. So students, it's nothing but we use normally we using the data types in C and all the other languages as an integer, as a float, as a double, as a character, as a string, as a pointer. Okay, these are all called primitive data structures. That's all. No need to worry about this particular topic. Already we familiar about this particular topic. Okay. In the next slide, we concentrate the non-primitive data structures. So in this, you are already familiar with the arrays. You are already familiar. There are more sophisticated data structures. These are derived from the primitive data structures. The non-primitive data structures emphasize on structuring of a group of homogeneous, that's the same type, or heterogeneous, different type data items. Okay, so that's a important thing. Here we store some group of data. We're storing some group of data. That group may be same type, homogeneous, or that group may be different, heterogeneous. Okay, guys, that's the thing here we concentrate. Okay, just wait. Go to the next slide. Here, non-primitive data structure. Again, list, stack, queue, tree, graph are example of non-primitive data structures. See, the students, here we concentrate only 4 to 5. That is list, stack, queue, tree, and graph. I already told to you, our next videos only come specifically come for these data structures. That is list, stack, queue, tree, graph. Okay. So next, the design of an efficient data structure must take operations to be performed on the data structure. Okay. To design of an efficient data structure must take operations to be performed on the data structure. Okay. Okay, guys. Okay, just wait. So again, the non-primitive data structure. The most commonly used operation on data structures are broadly categorized into following types. Okay, so commonly, what are the data types we are using for this non-primitive? Okay, like as a creation, selection, updating, searching, sorting, merging, maybe delete or a destroy. So these are all the common operations we are applying for the non-primitive data structures. Okay, that may be a stack, queue, linked list, and all the non-primitive. Okay, so in a linked list, take an example of linked list. So in that you want to create that linked list, and also you want to apply the selection. You want to update, you want to search, you want to sort, you want to merge, you want to delete. In that way, you want to perform these type of operations. These are, you want to apply these type of methods. Okay, nice. Next, different between them. What is the difference between the primitive and non-primitive? Okay, a primitive data structure is generally a basic structure that is usually built into languages, into the language, such as an integer or a float. Second, non-primitive data structure is built out of primitive data structures linked together in a meaningful way. Simply we combine the primitive, such as a or a linked list, binary search tree, AVL tree, graph. These are all examples. There is a list, tree, graph, stack, queue. Stack queue normally comes under that list or linked list. Okay. So here you want to know clearly about the difference between a primitive and a non-primitive. So I already told to you, students. So in this presentation, mainly we concentrate the arrays. Okay. That is, an array is defined as a set of finite number of homogeneous elements or the same data items. Here we have a finite number of elements, 20 elements, 10 elements, 30 elements. Okay. Initially, we fixed the size of an array. And also here we store only the homogeneous elements, same data type elements, only integer, only float, only character. In that way, we store only homogeneous elements or the same data items. Okay. Next, it means an array can contain one type of data only, either all integer, all float point number, or character. That we discussed already. That's the last point. Okay. Here, see this. It's a simple C language syntax for declaring an array of 10 finite elements. Okay, integer ARR, that is the name of that array. Okay, that is user defined. We can define. We only define that name, but int is the keyword. We can't change that, but we can change the name of an array. ARR. Instead of that, we can use AR or ARR for AY1. We can use N. We can use only A. That is possible, but the 10 is a fixed value. So you can change the 10 into 20, 30, 40. But anyway, initially you want to mention that count, fixed count. Okay. So that's where int specifies the data type of or type of elements arrays stores. ARR is the name of an array, and the number specified inside the square brackets is the number of elements an array can store. This is also called size or length of an array. Okay. See this. Following are the some of the concepts to be remembered about an arrays. Additionally, we want to know these additional information related to that array. The individual element of an array can be accessed by specifying the name of an array, following by the index value or subscript inside square brackets. The first element of an array has index 0 or 0. It means the first element and last elements will be specified like this. If you declare 1 to 10, so it starts with 0 to 9. Okay, respectively. Here also we have 10 elements. We starts with 0, we move up to 9. So 9 plus 0, 1, 10, totally 10. Okay, so that's a concept. Normally, some languages, the index value may starts with 0, ends with 9. The maximum 10 means ends with 9. Okay, if it is 20 means it starts with 0, ends with 19. Okay, so totally here we have 10 elements, or 0 to 19 means 20 elements. Okay, so the count only important, but some other language, some languages, they are starts with 1. The index value normally starts with 1, ends with that maximum value 1 to 10, 1 to 20, 1 to 40. 1 to 10 means we have 10 elements. 1 to 20 means we have 20 elements. Okay, so next, the elements of an array will always be stored in the consecutive memory location. That's very, very important. We need continuous memory location. If you declare integer a of 20, integer occupies 2 bytes, means 2 into 20, 40 bytes. We need continuously. Continuously, we need 40 bytes of memory location. Okay, so that's very, very important. The number of elements that can be stored in an array, that is the size of an array or its length, is given by the following equation. If you want to know the size of the array, means upper bound minus lower bound plus 1. Okay, that is 0. Upper bound is 9, lower bound is 0. So 9 minus 0 is 9 plus 1, 10. That is the length of an array. Okay. For the above array, it would be 9 minus 0 plus 1 is equal to 10. That's already we discussed that 0 is the lower bound of an array and the 9 is the upper bound of an array. Array can always be read or written through loop. Okay, so that thing we will see later. Okay, how the loop statements are executed, how we retrieve the elements from an array with the help of a loop statement. Okay, why we want to use loop statement, why we want to use conditional statements in C language, that we will discuss in later videos, later classes. If we read a one-dimensional array, it requires one loop for reading and other for writing the array. Then arrays, for example, reading an array. See here, in the for loop, I is equal to 0, I less than or equal to 9, I plus plus. And also you can use the scanf. It's purely C language syntax. Okay, here we retrieve the elements of an array. For example, writing an array. And also you can print the values. You can read the value with the help of scanf statement. You can print the values with the help of printf statement. Okay, so in this way you can do lot of things. Okay, lot of things. Okay, guys. Next slide. Here we discussed the same. How we create an array, how we traversing an array. Okay, we want to declare 20 elements array. We want to move one by one. Okay, we want to move all the places. That's the thing. Okay, then in arrays, what are the elements? What are the operations are possible? Means insertion of an element, deletion of required element, modification of element, merging. Okay, that's already we discussed. What are the possible methods in primitive and non-primitive data structures? Okay, students, I think it's the end of the session. Here we concentrate a lot of things. Okay, in this presentation or in this session, we start with introduction to data structures. Okay, the definition of the data structure. After that, two major subcategories, two major types or categories, primitive and non-primitive. And then we are seeing under the primitive what are the data structures are there, under the non-primitive what are the data structures are there. After that, we concentrate only about an array. In this presentation, we mainly concentrate the arrays. Okay, the syntax is using C language, or is using C language. I think it's very useful to you. Okay, so in the next video or in the next session, we will see about the stack operations. After that, queue operations, then linked list. In this way, we move one by one. Okay. Okay. Anyway, thank you, students. Thank you. Thank you.